Question 13. We're told that a piston is undergoing simple harmonic motion. The differential equation for which is d2x dt squared is equal to negative 9x. We know in general that we have x double dot is equal to negative k squared x. So from here we can recognize immediately that k is equal to 3. In part A, we're asked for the period of the motion. We know for the general situation that t is 2 pi divided by k, so here t is going to be 2 pi by 3 seconds. We're now told that the maximum speed is 5 meters per second. We want to find the amplitude of the motion. The maximum velocity is always given by k times the amplitude. So we're given that the maximum speed is 5, and we know that k is 3. So A must be 5/3 of a meter. Now for part C, we're told the amplitude and period of the motion are now changed, although we're still undergoing simple harmonic motion. We're given the following information. When x is 1 meter, the speed is root 60 meters per second. When x is 3 meters, the speed is the square root of 28 meters per second. We want to find new exact values for the period and the amplitude of the motion. We know the formula V equals K root A squared minus X squared. That gives us that V squared is equal to K squared into A squared minus X squared. Using this information gives us 60 is equal to K squared, A squared minus 1. Let's call that equation 1. Using this information gives us 28 is K squared into A squared minus 9. We can solve these simultaneous equations by dividing. If I do equation 1 and I divide it by equation 2, I get 60 over 28 equals K squared, A squared minus 1 over K squared, A squared minus 9, and the K squareds cancel. We want to solve the equation that we have. A good way to set this up is using fraction templates so it looks exactly like it does on the page. So we need a fraction template on either side. In this fraction we have 60 over 28, and on this side we have x squared minus 1, and on the bottom we have x squared minus 9. Then execute, and we know that the answer we want is the positive one. So we now have that A is equal to 4. Substituting back into 1, we get 60 is equal to 15k squared. So k squared equals 4, giving us that k is 2. Remember, k is always a positive constant. So the period is 2 pi divided by 2, giving us pi seconds. And the amplitude, we know, is 4 meters.